Hello everyone, my name is Vipra Joshi and I am an assistant professor in St. Andrews Institute of Technology and Management in Electrical Engineering Department. Today I am going to deliver a lecture on subject of transmission and distribution. In this video, I will be explaining radio interference. This is Unit 4th topic of 4th semester in Electrical Engineering branch. Radio interference comes from the corona. Corona on such equipment as busbar and insulator. We know about the corona effect. Okay, so when the electrical field strength on the surface of busbar and insulator, and we can say the other energized conductors in the switchyard exceed from the critical voltage, then it is the resulting of the ionization of the surrounding air followed by the corona discharge. So we can say this discharge is also the reason for the radio interference. So we can say radio frequency spectrum is generated by an external source, and so this affect the electrical circuit by the radio interference, and we also call this electromagnetic interference. And disturbance external source that affect an electrical circuit by electromagnetic induction, electrostatic coupling or conduction. Now, high voltage transmission line and substations can cause the radio interference. Since radio noise is associated with the corona, okay, so it mainly depend on the potential gradient of the conductor. So all the effects which are affected the corona is also affected the radio interference, like air density, humidity, wind contaminate. Okay, so the radio noise in the bad weather is about to 10 to 25 dB higher than the radio noise during the fair weather. The radio interference is caused by the electromagnetic wave in the frequency range of the broadcast frequency. This frequency of the range is 0.5 to 1.6 megahertz. So between this we can see the radio interference, and we can say the radio interference occur. And by using the bundle conductor and surface voltage stress and corona, and radio interference can be reduced. We can say by using the bundle conductor we can reduce the corona and radio interference, because we know that electrical field around the conductor causes the corona. Hence, to reduce the corona and radio interference, we should try to reduce the electrical field around the conductor surface. Okay, so we can reduce is either increasing the diameter of the conductor or arranging the conductor in set of 2, 3 and 4 type phase. So the arrangement of the conductor in set of 2, 3 and 4 per phase, this is called the bundling of the conductor. So By the bundling of conductor, we can reduce the corona and also reduce the radio interference. Inductive interference between power and communication line. Corona produce inductive interference between the transmission line and the wireless line signal. Okay, so it produces a disturbance in between this line. So radio interference due to the corona is of the importance for the line above the 200 kilovolt. It means we can see the corona and radio interference occur above the 200 kilovolt line. And the next is the electromagnetic and electrostatic effects mainly depend on what is the distance between the power and communication circuit and the length of the route over which they are parallel. It means we can say these are depend on the distance between the power and communication circuit and also the route length in which they are parallelly arranged. Okay, so the unacceptable distance which is produced in the telephone communication because of power line is called the telephone interference. What is telephone interference? Telephone interference occur when unwanted radio frequency signal which produced by the corona, so these frequency signal disrupt the use of our television and radio, and we can say cordless telephones. So it destroy the signal of our television and telephone and radio. So it may cause only a temporary, and there is a temporary loss of the signal. So it can also affect the quality of the sound and picture produced by the equipment at that time when these losses occur. Okay, so the radio produce hissing, cracking noise, and also when we go too close to the line, okay, so we can hear the hissing sound, but the disturbance disappearing fast as we drive away from the crossing of the highway. So corona is the reason for the radio interference, and the other reason is the discharge in the faulty insulator. This discharge generated by the sparks and other sharp object subjected to the electrical field. Okay, so the sharp object produce an increase in the local electrical field. So due to the electrical field production, this can be lead to the surface discharge, and we know that this discharge produce the radio interference, and we can say it decrease with the distance from the line. Now there are various factors influencing the telephone interference. These factors are because of harmonics in the power circuit, their frequency range and magnitude. It means due to the harmonics in the power circuit, it affects the frequency range and magnitude. Okay, so electromagnetic coupling between the power and telephone conductor, this is the other factor which influence the telephone interference. Okay, so due to unbalance in power circuit and in the telephone circuit. And next is type of return telephone circuit, it means either metallic or ground written. So type of written telephone circuit is also affected the we can say it is also the factor of the influencing the telephone interference and screening effects. This graph shows the measured frequency spectrum curve of the radio interference in the ultra high voltage substation. So here we use this sign for the incoming line side when substation equipment is energized, and we use this sign for the switchyard side when the substation equipment is energized, and this sign is used for the outage of the substation. So here you can see that this is the horizontal axis. Here we take the test frequency, and this is the vertical axis. Here we take the radio interference. So in this figure, and we can say in this diagram, we can see here radio interference at various frequency decreases. Here you can see radio interference decreases with increasing in the test frequency. Okay, so at 1 megahertz the frequency is 40 of the outage substation and 50 of the incoming line side substation, and above than 60 when switchyard side substation. Okay, so here you can say the radio interference is decreasing with increasing the test frequency. Okay, and you also see that at the 10 megahertz, okay, and above it the test frequency is very increases, but the radio frequency is decreases very little. So when substation equipment is energized and de-energized, then we can say radio interference at the 10 megahertz and above it is very small, and we can neglect it. You can see here this is the radio frequency. Okay, so from here to here it is decreasing like this, and now when it reaches to the 10 megahertz it decreasing slowly, means the response of the radio frequency slowly at the test frequency is increasing from 10 megahertz to 100 megahertz. Okay, so we can neglect this effect. So we can take the baseline as a 10 megahertz. And similarly, radio interference from the DC transmission line is same. Okay, and this interference in the DC transmission line is mainly sourced from the positive plate conductor. So this is the graph of the radio frequency with respect to the test frequency. Thank you.